Well, today I would like to introduce one problem on prime numbers under mathematical thinking category. You know prime numbers, right? Not Amazon Prime, but prime numbers in mathematics. Fine. How do you define a prime number? A number which has no factors other than itself and 1 is defined as a prime number. What's the other way of defining it? A number with only 2 factors is also defined as a prime number. Of course, both are same. And 2 is the least and even prime number in the entire set of prime numbers from 2 to infinity. 1 is neither composite nor a prime number. You know all these fundamental stuff, right? Fine. By keeping all these fundamentals in your mind, let me introduce the problem. It goes like this. The number 907 is prime because it has no factors other than itself and 1. But to prove that 907 is prime, you must check to see that it's not divisible by any of the prime numbers starting from 2, 3, 5 and so on. Now the question is, how far do you want to go before you conclude that 907 is a perfect prime? So first understand the problem. You got the problem right. The question is clearly asking you about up to what prime number you wanted to check before you conclude that the 907 is prime. Because there are many prime numbers in between 2 and 907. Do you know what is the previous prime number for 907? 887. So in between 2 and 907 there are many prime numbers. So the question is asking you about how far do you want to check, up to what prime number you wanted to check to conclude that the 907 is a perfect prime. For example, there are many prime numbers after 2, 3, 5, 7, 11, 13, 19, 239 and up to 887. So the question is asking you about, for example, do you want to go and check up to, let's say, 19 or let's say 29 or let's say 239 or up to 887 is the question to be answered. Now I suggest all of you to stop watching the video for the solution part, and I suggest you to try this problem on your own. Give a thought on this, give a trial on this. So later on you can come to the solution part. Fine. Now we'll go to the solution part. The solution part goes like this. To prove that any given number is a prime, you only need to check as far as the largest prime number less than its square root. The question is why? This is because in a pair of factors for any number, one factor will be always higher than its square root and other will be the less. In case of the given number is a square number, then it will have 2 factors that equal one another. But here we are not going to waste our time in proving that a square number is not a prime number. But the point here is that if you have not come across any factor by the time you reach its square root, then you will never get a factor after its square root. So in the case of 907, the root of 907 is equal to 30.116. Therefore the largest whole number below its square root is 30. Therefore the largest prime you need to consider is 29. It does mean that when you are checking for the prime numbers, if you have not come across any factor by the time you reach 29, then you can clearly conclude that the 907 is a perfect prime. But if you get a factor when you have checked and when you are reaching 29, then 907 is not a prime. That's how you can make the conclusion.